What's the matter, Carlos?
It's a lot of work.
You're right, but not the kind of work you're thinking of. Did you know that there are a lot of forces at work when you mow the lawn?
Forces like Yoda in Star Wars?
Forces like gravity and the pushing force created by you, Carlos. Let's consider your pushing force. When you mow the grass, you create kinetic energy. Kinetic energy is defined by half times mass times velocity squared. M is mass of the mower, and V is speed of the mower in meters per second.
So how does kinetic energy relate to work?
By using the work energy theorem. The work energy theorem states that the final kinetic energy minus the initial kinetic energy is equal to the total work done by the acting force. Since the motor starts at rest, the kinetic energy is zero because there is no movement. The final kinetic energy is measured just before the mower stops.
So since the initial kinetic energy is zero, then the work is done by the final kinetic energy.
True that, Carlos. And keep in mind, work is measured in joules.
What, like watches and earrings?
No, Carlos, joules. The work energy theorem can even be applied when you throw your yard cuttings away. This time, the acting force is gravity. The energy involved here is potential energy. Potential energy is defined as mass times gravity times height. Keep in mind, gravity is always 9.80 meters per second squared. According to the work energy theorem, the total work done by gravity is the starting potential energy minus the final potential energy when the bag hits the bottom.
So when the bag hits the bottom, there is no height, so the potential energy is zero?
That's right, Carlos. So the total work done by the force of gravity is equal to the initial potential energy.
Wow, that is a lot of work.
It certainly is, Carlos. Now, you can truly appreciate physics when you mow the lawn.
Thank you, physics!